So we want all those things in a crypto system. That sounds great. So let's look at these intersection points. Where can quantum and classical coexist and meet each other? And so there are integrations at different abstraction layers that we can consider. Okay, so even one step further, let's consider applications, right? How can quantum and classical coexist at the application level? And how do we maintain notions of security for these applications that we know of today and applications that may be discovered in the future? So we already know that quantum-enabled data centers are being built, right? And there are some pictures and some announcements there from companies like IBM, IonQ, PsiQuantum, really going full steam ahead on these modular approaches and coexistence with classical computers as well. So these quantum data centers are being built, and it still remains to be seen how quantum computers will actually be consumed by end users. If this is going to be a big cloud play, so we're going to be accessing quantum computers over the cloud versus on-prem, that remains to be seen. But in the case of accessing these data centers over the cloud, we can consider protocols like blind quantum computing or distributed quantum computing, where these data centers can work together and do a quantum computation while also maintaining that secrecy to the user, right? We don't necessarily want the cloud vendors or the manufacturers to know the sensitive data that I'm encoding in my circuit, or the circuit itself, right? This might be intellectual property. You might be encoding sensitive, patient data or financial data or scientific data into your algorithm. So with these protocols, we can really maintain that notion of security and privacy. So that's on the computing side, and then on the sensing side, there's position, navigation, and timing applications for quantum sensors that can really help enable a lot of value in military applications as well. I'd like to shout out this Quantum Protocol Zoo. This is one of my favorite kind of websites to go through. This was done by VeriCloud, and essentially, there you can see all of the cool applications that we can envision with such an advanced secure network with entanglement, right? What can we do with entanglement? We spoke about cybersecurity applications, we spoke about computing and sensing, but there are more, maybe a little further out there, applications that we can consider. Things like using entanglement to have more trustworthy voting systems. There are even proposals for things like quantum money. Byzantine agreement can be helpful for political discussions and things like that too. So who knows what the quantum internet will bring, but we need to be ready for that, and we need to build up notions of security from the ground up. And we didn't do this in the internet. Security was kind of thrown on top after we realized that it will be an important thing for future applications. But now we know it is important. It's going to be increasingly important. And we need to be ready for that transition.